Have you ever really stopped to wonder how our ridiculously complex world gets translated onto that map you're looking at on your screen? Well, today, we're going to pull back the curtain on the amazing technology that makes all of that possible.
Okay, so think about this for a second. How does a city actually figure out the absolute best spot for a new park? I mean, they can't just throw a dart at a map, right? They've got to consider who lives where the bus stops are, and, where the other parks already are. It's a huge puzzle.
Or, let's flip it to the business world. How does a giant coffee chain know exactly which street corner is the perfect spot for their next store? They're looking at everything: traffic, who lives in the neighborhood, and you better believe they know where every single competitor is.
You see, both of these are what we call where questions. And honestly, in our world today that's just drowning in data, answering the where is a massive, massive challenge. You're not just looking for an empty space. You're trying to see these invisible patterns and connections that are woven into the very fabric of a place.
So, how in the world do we solve it? Well, we use this special kind of answer machine that was built from the ground up to tackle exactly these kinds of questions. It's called GIS.
So, what is GIS? Well, at its heart, a geographic information system is a computer system that's designed to capture, store, analyze, and display what we call geospatial data. And that's just a fancy way of saying it's information that's tied to a specific location right here on planet Earth.
And the name itself pretty much tells you the whole story. Geo, that's our world. Graphic is the map, the picture. Information is all the juicy data we can attach to a place, like how many people live there, how high it is, what the soil is like. And system? That's the computer that brings it all together and makes sense of it.
The whole process is actually super logical. It follows this really clear workflow. First, you capture the data. You're getting it from satellites, drones, you name it. Then, you store it, but you do it in these neat separate layers. It's kind of like stacking transparent sheets on top of each other. You've got one for roads, one for rivers, one for buildings. Now, the real magic happens in the analyze step. This is where you see how those layers interact, finding connections you would have never noticed. And finally, you display your discoveries on a map for everyone to see.
Okay, but how does a computer actually see our physical world? I mean, it doesn't have eyes. Well, GIS basically has two fundamental ways of understanding what's out there. So on one hand, you've got what's called vector data. Think of this like a super precise drawing or a blueprint. It uses distinct points, lines, and shapes to map out things that have really clear boundaries. Then on the other hand, you have raster data. This is way more like a photograph. It uses a grid of tiny cells, or pixels, to show information that flows and changes across a landscape. Stuff like temperature or the slope of a hill. Let's make that real. For vector data, a single point could be a fire hydrant or a specific building. A line could be a street, a river, or a pipeline. And a polygon? That can perfectly trace the outline of a city boundary, a national park, or even your own backyard. It's all about those separate, well-defined things.
And raster, well, think about stuff that doesn't really have sharp edges, things that kind of blend into each other. A satellite photo of a forest, a weather map showing temperature, or the gentle slope of a mountain. All of that is captured perfectly in that pixel-by-pixel grid.
So we have these two really clever ways of seeing the world digitally. But here's the kicker. Here's why it's so incredibly powerful. When we start combining these different layers of data, we can make smarter, faster decisions that, honestly, shape our world every single day. For instance, police departments aren't just mapping where crimes happen. They're layering that data with the time of day, with population info, even with where the streetlights are, all to predict where the next hotspot might be. It's about being proactive, not reactive.
Or think about this. By layering elevation data with weather models and soil types, emergency crews can create these scarily accurate flood maps that lets them issue super precise evacuation warnings that literally save lives when a big storm hits.
And hey, remember that coffee shop from the beginning? GIS is their secret weapon. They layer their own sales info with traffic data and census information to find that one perfect intersection that has just the right mix of people to sell coffee to. And this isn't just local stuff. On a global scale, conservation groups are using GIS to compare satellite images from this year to last year, spotting illegal logging in places like the Amazon almost as it's happening. It's like having a watchdog in the sky.
And right here in our cities, GIS is basically the conductor of a huge, invisible orchestra. It helps plan new bus routes by seeing where people live and where they work.
It makes sure fire trucks can get anywhere in just a few minutes. It manages that huge tangled web of pipes and cables running right under our feet.
When you boil it all down, the one thing to remember is this. GIS is the bridge. It connects the where of a place with the what of that place. It turns a simple, flat map into this living, breathing story of our world.
By layering our world with all this information, GIS gives us this incredible, almost superhuman ability to see the patterns that have always been hidden in plain sight. And that leaves us with this one big, exciting question. Now that we have the power to map almost anything, what's the next great where challenge that we're going to solve?